Yo, what's good, dudes? I'm exhausted. I'm like really tired. I should probably be asleep. And someone got very, very mad at me, my parents. But anyway, today we're gonna be going over the quadratic formula, and hopefully you are able to hear me because like I'm so tired. And like bro, it's just so I'm just exhausted. But we're gonna be going over the quadratic formula today, why it works and why you should use it more often. And honestly, I guess for some people, the biggest problem with the quadratic formula is just trying to remember all of it because like it's like oh my god, it's like the big ass equation like yeah 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 yeah. Oh my god, water just fall down my face. Holy shit! But anyway, the quadratic formula, and this is the reason why I decided to make this video. Since I'm half asleep, I'm gonna regret this, but oh my god, let's just do this. So if you want to remember the quadratic formula, you just gotta remember the song. And shout out my goat, Miss Win. She taught it to me. Yeah, I'm gonna regret this shit. Opposite of B, opposite of B. Yo, where's my opposite of B game? Opposite of B, opposite of B. Plus or minus square root, plus or minus square root. B squared minus 4AC, B squared minus 4AC. All over 2A, all over 2A. So essentially, that is your formula with a fun nursery rhyme, which is the easiest way to remember it. Now you should have it memorized, right? Congrats. You solved every problem in the world. Congratulations. Go become valedictorian now. I'm playing. We're going to see why it works exactly. So let's go on to our first example. We have x squared minus 5x plus 6 equal to 0. Obviously, you want everything to get moved to the left side or to the right side in order for x squared to be negative or positive. So we have x squared minus 5x plus 6 as our first one. So obviously, if you're pretty genius or a nerd or both or just straight up, guessing, you can see that you can get the roots by the solution by just factoring. So really, you could just do x minus 3, x minus 2 equal to 0. And then from here, your solutions are just x equals 3 and x equals 2. But however, if you weren't able to factor that quickly as me, then your quadratic formula might be another solution for it. So let's just write it down. Opposite of b plus or minus square root. Opposite, oh my god, you see where that works? Plus or minus square root. B squared minus 4ac. Yeah, okay, it works. It works. All over 2a. So essentially what we're going to do here, we're going to label each number as a, b, and c. So essentially, you're going to want to look at the coefficient of that formula and see which one it is. Obviously, x squared is not that obvious, but there's a hidden one right here because 1 times x squared is just x squared. So essentially, your a is equal to 1, b is equal to negative 5, and your c is equal to 6. So from here, you could just plug in all your numbers, coefficients, into the quadratic formula. So it's going to be negative 5 plus or minus square root. Negative 5 squared is 25 minus 4 times a, which is 1 times 6 all over 2a, which is 1. So from here is going to be negative 5 plus or minus, did I mess up? -25 minus 4 times 6, which is 24, all over 2. Oh my god, I know. Oh, you see what I mean by I'm half asleep? B is negative 5. Opposite of B, this is supposed to be positive. Oh my god. And then it's just going to be 5 plus or minus square root of 1, which is just 1, all over 2. So essentially from here, you could just do 5 minus 1. So you have 5 minus 1 over 2, and then 5 plus 1 over 2. 5 minus 1 is 4 divided by 2 is equal to 2. 5 plus 1 is 6 over 2, which is equal to 3. So the quadratic formula works. We've established that. And hopefully you'll mind my little errors because I am seriously half asleep. The second formula we're going to go to is 2x squared plus 4x minus 5 equal to 0. And so this is going to be a little bit weird because you can't exactly factor this like that. But obviously, we're going to use the quadratic formula to our advantage. So we're going to write it down. B squared minus 4ac. B squared minus 4ac. That's my favorite part. Now we're going to label our A and B and C. A is going to be 2. B is going to be 4. And C is going to be negative 5. Remember, always remember to include the negative, no matter if it's B. You saw my mistake. Please do not be like me. Do not be like me. Be better than me. Do as I say, not as I do. Yes, I got that quote right. So now we're going to plug in everything to our quadratic formula. So opposite of b is going to be negative 4 plus or minus b squared, which is 16, minus 4. A is 2. C is negative 5. And here's the important part. All over 2a, which is 2. So from here, you get negative 4 plus or minus square root of 16 minus 4 times 2 times negative 5. Now, this is very important. Since you have 16 minus a negative number, that means you're going to add it on. So it's going to be positive 16 plus 4 times 2, which is 8, times 5, times negative 5, which is negative 40. And then you're going to add that on. I believe so. All over 4. And then from here, you have negative 4 plus or minus root of 56, I believe, all over 4. Now, from here, you can say that you're done and just not simplify. However, there's this thing called radicals. So essentially, when you're simplifying a radical, what you want to do is you just want to use that part. You just want to find the highest square that can be divided by the number. Here's what I mean. So essentially we have 56, and what we want to find is the highest square that it can be divided from. So our squares are going to be numbers like 1, 4, 9, 16, 25, and 36. So the reason why we're going to do this is because we can radicalize it, which means that when we divide this number by its square root, we're able to take a perfect square and just simplify it down to like a lower form, essentially. It's not meant, if you're an AB, you don't really have to do it. If you ever get a question like this, I don't know why you would. However, it's just good practice. So from here, we're going to simplify. It's going to be red now. So the highest square that we can divide 56 by is 4. Because 9 doesn't work, 16 is too big, 25 is too big, and yada yada. So from here, we're going to separate into 4. And I believe 17, because 17 times 4 should be 56. Let me check. Nope, I am dumb. Okay, we're going to do this the hard way. You see what I mean by half asleep? Okay, it's 14. Cool. Not 17, but 14. Don't mind my mistake, please. And so from here, we're going to take square root of both of them. And you can actually simplify 4 into 2 by the square root. And then we're going to leave 14 as so. And it makes sense. It makes sense. So now from here. Oh, and the reason why radicals work is because if you were to square them, you get 56. Because root 56 squared is just 56. And you'll get the same thing here. So obviously you have to square everything inside. It's just 4 because 2 squared is 4 times 14 squared. Root 14 squared is just 14, which is just equal to 56. So radicals work. So from here, after going off that big ass tangent, you're going to simplify negative 4 plus or minus root of 56 into negative 4 plus or minus 2 root 14 over 4. And you can simplify this more by just dividing by 2. So you're going to get negative 2 plus or minus root 14 over 2 as your answer. Obviously, I don't have a calculator, so I can't really give it to you, the answers, but just trust me on this one. So the last one is going to be quite an interesting example, I would say. So we're going to do x squared minus 2x plus 5. And so obviously we're going to write down our equation. And then from here, we're going to label our A, B, and C. So from here, we have A is equal to 1. Don't remember, invisible 1. So it's going to be 1 as A. B is equal to negative 2. Remember that. And C is equal to 5. So from here, what we're going to do is we're just going to plug every number in as usual. How we've been doing. Opposite of B, opposite, opposite, which means it's positive. Don't do what I did, okay? And then B squared is going to be 4 minus 4 times A, which is 1, C, which is 5, all over 2A, which is 2 in this case. From here, we're just going to simplify our formula into 2 plus or minus root of 4 minus 4 times 1, which is 4 times 5, which is 20. Wait a minute. Wait, this isn't... What the fuck? Wait, what the fuck? Yeah, so we kind of run into a problem. You can't really get a negative 16 root because that's like fucking impossible. I assure you it's not. So here's what we're gonna do. From here you're gonna stop bitching and nah, I'm playing. From here what you're gonna do is you're gonna turn into that root negative 16 into a 4i. Or a 4 times imaginary number. So essentially, if you haven't been taught this, I will teach it to you right now. An imaginary number is imaginary. It's just something called in the complex plane. You'll learn it later in math. For Algebra 2, as of right now, if you're watching this, all you need to know is that I is equal to the square root of negative 1. The reason why that works is because you can't ever square a number and then get a negative number out of it. Because if you square a number, you're going to get a positive number. If you have a cubic root, however, that's different. But we're not dealing with cubic roots, we're dealing with square roots, so that's different. So essentially, I is equal to root of negative 1. I squared is equal to negative 1. I cubed is actually equal to negative I. The reason why that is because you have negative 1 times root negative 1. And we've established that root negative 1 is just I. So you have negative I. And then I to the 4 just brings you back to, I believe, root negative 1. Am I right in making that assumption? I think I'm wrong on that one. But just have to know these ones. These are important ones. So now essentially, for root negative 16, if you're good at patterns, you can know that root negative 16 is root of 16 is just 4. It's just going to be 4i. So essentially, we can actually simplify this number to be 2 plus or minus 4 times the imaginary unit over 2. I think I can break this down even more. I think. Oh, can I? Yeah, I think I can, because I can just do 1 plus or minus 2i. And that's your answer. Yeah, you actually can break it down. So essentially, even if you think you have no like answers, you still do, they're just imaginary. And you might be like, well, imaginary is so useless right now. Promise you, there's like many applications in engineering and applied mathematics for imaginary numbers. So we're not all useless. Essentially, you know, you can use the quadratic formula to find these roots. Very, very special roots. But essentially, that's been my video for the quadratic formula. Thank you for watching. If you've enjoyed, please leave a like, subscribe, share this video out with your friends. I am half asleep. It is 3 in the morning. I am really, really tired. So hopefully you enjoyed the video. Thank you for watching, and goodbye.